Net zero carbon, often shortened to net zero, means achieving a balance between the amount of greenhouse gases, primarily carbon dioxide, CO2, emitted into the atmosphere and the amount removed from it, resulting in no net increase in atmospheric greenhouse gas concentrations over a specified period, usually a year. Net acknowledges that it's very difficult or impossible with current technology to eliminate all emissions from certain sectors like aviation, heavy industry, agriculture. Some residual emissions will likely remain. Zero means these residual emissions must be counterbalanced by removing an equivalent amount of CO2 from the atmosphere. It's not the same as zero emissions, gross zero, which would mean emitting absolutely no greenhouse gases at all. Net zero allows for balancing unavoidable emissions with removals. Why is net zero important? To limit global warming to well below 2 degrees Celsius, preferably to 1.5 degrees Celsius, compared to pre-industrial levels as per the Paris Agreement. Stabilizing the climate requires stopping the net accumulation of greenhouse gases in the atmosphere. Net zero is the point where we stop adding to the problem. How to achieve net zero carbon? Achieving net zero is a massive systemic transformation requiring action at all levels: individual, corporate, city, national, global. Here's a roadmap. Deep and rapid emissions reduction the priority. Transition to renewable energy. Phase out fossil fuels, coal, oil, gas, for electricity generation and replace them with solar, wind, hydro, geothermal, and tidal power. This is the single most critical step. Electrify everything. Shift energy use in transport, buildings, and industry to electricity generated from renewables. Transport. Mass adoption of electric vehicles, cars, buses, trucks, investment in public transport, cycling, walking infrastructure, and development of zero-emission shipping aviation fuels, each are green hydrogen, advanced biofuels. Buildings. Improve energy efficiency, insulation, efficient appliances lighting, switch heating cooling to electric heat pumps, use renewable energy sources. Industry. Improve energy efficiency in processes, switch to electric heating, hydrogen where possible, implement carbon capture for hard-to-abate processes. Stop deforestation and restore ecosystems. Protect existing forests, peatlands, and mangroves, major carbon sinks, and undertake large-scale reforestation and afforestation projects. Sustainable agriculture. Reduce emissions from livestock methane, improve manure management, optimize fertilizer use, reducing N2O, adopt regenerative farming practices that sequester carbon in soil. Reduce waste and promote circular economy. Minimize waste generation, maximize recycling, reuse, capture methane from landfills, shift from a linear take, make, dispose to a circular economy model. Scale up carbon dioxide removal, CDR, to counterbalance residual emissions. Natural solutions. Enhance natural carbon sinks through reforestation, afforestation, improved forest management, soil carbon sequestration in agriculture, and restoring coastal ecosystems. Blue carbon, mangroves, seagrasses, salt marshes. Technological solutions crucial for hard-to-abate sectors. Direct air capture, DAC, machines that chemically capture CO2 directly from ambient air. Bioenergy with carbon capture and storage, BECCS, growing biomass which absorbs CO2, burning it for energy, capturing the emitted CO2, and storing it permanently underground. Enhanced mineral weathering, accelerating natural processes where rocks absorb CO2. Carbon capture and storage, CCS, capturing CO2 emissions at the source, e.g. power plants, factories, before they enter the atmosphere and storing them geologically. Primarily a reduction strategy for point sources, but also part of CDR like in BECS. Supporting mechanisms and enablers, policy and regulation, government mandates, e.g. phase-out dates for IC vehicles, coal plants, carbon pricing, taxes or cap and trade, subsidies for renewables, clean tech, energy efficiency standards, green procurement policies, investment and finance, massive redirection of capital flows away from fossil fuels towards clean energy, efficiency, and CDR technologies. Green bonds, climate finance, and ESG investing play crucial roles. Innovation and R&D. accelerating development and cost reduction of key technologies, renewables, batteries, hydrogen, CDR, sustainable fuels. Behavior change and demand reduction, encouraging sustainable lifestyles, less flying, reduced meat consumption, energy conservation through awareness, incentives, and infrastructure. Global cooperation and equity. Developed nations must lead and provide significant financial technological support to developing nations for mitigation and adaptation. A just transition is essential. Robust monitoring and verification. Transparent systems to accurately measure emissions, reductions, and carbon removals, preventing greenwashing. Key challenges. Scale and speed. The transformation needs to happen globally and within decades. Cost. Significant upfront investment is required, though long-term savings and avoided climate damage are enormous. Technological maturity. Some critical CDR technologies like large-scale DAC are still nascent and expensive. Political will and policy consistency requires sustained commitment across political cycles and borders. Equity and justice. Ensuring the transition is fair and doesn't disproportionately burden vulnerable communities or developing nations. Infrastructure requires massive new infrastructure, renewable grids, EV charging, CO2 pipeline/storage. Achieving net zero is the defining challenge of our time. It demands unprecedented collaboration, innovation, and commitment across governments, businesses, financial institutions, and individuals worldwide. While immensely difficult, it's technologically and economically feasible and necessary to secure a livable planet. Comment your thoughts about achieving net zero carbon. Like and share this video and subscribe Climate Action with Mudassir channel.